Great. Well, thank you all so much for joining this first in a three-part training series on starting community composting programs on tribal lands. In these next 90 minutes, we'll cover compost, what it is, its benefits, and how to do it. Today, we'll be really focused on the basics, and then the next two sessions will be much more grounded in looking at and then sharing examples of community composting approaches and programs that tribes have implemented and explored, have implemented on their lands. And then the third session will really get into exploring a planning framework that might be useful for tribes when starting or looking to expand your composting programs. These three webinars are part of US EPA's Waste and Materials Management Training Series for tribes. And they've been organized by US EPA Region 9 and 10 with the support of Booz Allen Hamilton. I'm Jenny Stevenson with EPA Region 9 covering here in the Pacific Southwest. I'm part of the team that helped bring this training to you all, and I've had the honor of working with tribes primarily in Nevada for the last 7 years on solid waste management programs. But I also work on our Sustainable Materials Management Program with a focus on sustainable food management. In this series, both today and our subsequent ones, we're really focused and all about composting. However, as we'll touch on, food wasn't grown, transported, harvested, or grown, harvested, then transported and sold to then rot in your fridge to be turned into compost. So while we're focused really on the end composting and recovering it and keeping it out of landfills, there are a lot of interventions and resources and tools that can help you with increasing food recovery. So I invite you to think about the sources of your composting program and consider that if there are possible other interventions that you could first put in place to help that food go towards its best use of feeding people or animals. And in this training, we'll point you to some resources that can help you with increasing food recovery. And then for what can't be fed to people or to animals, of course, compost it. And so that's what we're doing today. So a bit of a disclaimer. While these webinars are provided by EPA, they do not constitute EPA policy, and any mention of trade names or commercial products or external websites do not imply any official EPA endorsement. Okay, with the disclaimer out of the way, now that we've covered that, please allow me to warmly welcome you. I am so glad you're here. And my goodness, there is so much going on and so much being asked of all of you right now as we adjust to changes in our work and doing our part to stay healthy and limit the spread of COVID, caring for our families, and caring for our communities. And I also want to acknowledge, like everything that's going on with the fires and poor air quality and heat waves and extreme weather events that are impacting far too many people. And acknowledging all that, I just really appreciate and want to thank you for showing up here today, for being with us. We on the planning team all wish that we could be together in the field with our hands in the compost, touching it, smelling it, being together, having a lunch break all together in the training program. But one of the great advantages of being in this online space is that we're able to be joined by folks from all across the country, from New England to the Great Lakes, to the Southwest, the West, and up to Alaska. So thank you all for coming together. And in this series, we look forward to the questions and the discussions of how composting approaches have been adapted to all those various conditions, the wet, the arid, the freezing climates, and the feedstocks that might be unique to your place, like an abundance of wood or fish or citrus. So we hope over these next 3 sessions, you bring your questions and you share your experiences and successes. We really appreciate you being here, choosing to invest your time and intention on this. And we hope that you walk away with a new idea or approach. And so with that, let's get a quick sense of the soil conditions here with a quick poll. And we'd like if you could respond to how would you describe your knowledge of compost? Are you a seed, a seedling, and more of an established plant, or you're a full-on blooming flower? So if you could take a minute to respond to that polling question. And while that poll is going, I just want to note that while all the lines are muted because we are recording the session and we'll have it posted on our website here in a bit. However, just because the lines are muted, we don't want to mute your questions or your sharing of tips and thoughts. So please utilize the chat and the Q&A box. And after the session, I'll be sending out the PowerPoint slides, so we'll have that. And as soon as the link and the to the training is available, we'll be sending that around as well. So now I want to turn it over to our moderator, David Stitzel with Full Circle Environmental.
Great, thanks so much, Jenny. And you really can feel just how many people are on the call. It's quite exciting. So hi, I'm David Stitzel of Full Circle Environmental, Seattle-based resource conservation consultancy, and I'm part of the Booz Allen team that's providing contractor support for EPA for this training. So before I introduce Stephen, just a few quick housekeeping notes for everybody. I'm going to be keeping time today. So I'm going to work to move us along, keep us on schedule, and that means I may interrupt from time to time. So that's just in an effort to keep us moving along, nothing more than that. Also, as Jenny noted, lines are muted, but we really do want to hear from you. So if you have general comments that you want to share with the group because you want to kind of get that information out to everybody, please share that via the chat function. You'll see that over on the right if you've opened that column or that frame. And then if you have specific questions that you want to pose to Stephen for him to clarify or address, please use the Q&A function. And you may need to go to the bottom to your toolbar and click on those three dots. That's what I had to do. And when you click on the three dots, then you can open the Q&A box and it'll open in the column on your right. So again, chat is just to get things out into the zeitgeist for everybody to kind of see and hear and think about. But the Q&A box is for us to keep track of questions for Stephen. I'll be monitoring both of those and we'll pose questions to Stephen as time allows and as we move through the agenda. So that brings us to Stephen Sherman. Stephen's a resource economist and a planner by training. He's a leading technical and policy expert on the development of municipal organics programs. And he's just got incredible experience in consulting, research, operations, policy, education, and training efforts like this over a 30-year period. And he's really helped to lay the groundwork for food scraps management as a cornerstone of zero waste activities and recycling. Many of his clients have even won awards for the work that he's helped them with in organics management. And way back in 1992, last century, Stephen co-founded the California Organics Recycling Council. So let me just say that I've worked with and known Stephen for many years, and I can verify that the scale of his expertise and the success of all of his composting programs are really only exceeded by the size of his heart. And I think you will see that today. So let's go on to the next slide, and I'm going to give the 40,000-foot view overview of what we're doing today. Our objectives. So session one, that's today in the red box. We're going to describe compost and its benefits. What is compost? What are the benefits of it? What is the science behind it? Next time, we're going to have a more interactive session. The learning objective will be to identify community composting practices and techniques that might work well in your specific community. So we'll be looking at methods, we'll be looking at profiles of community composting programs. And then finally, in the third session, the learning objective is to navigate a path to developing and managing a community composting program. So that really requires us to assess needs and capacity and do some actual program planning. So our goal is really that you learn something in each session, and that by the end of the series, we want you to develop the confidence and base of knowledge so that you feel really ready to get started in developing and implementing a program in your community. Please also note, as I just alluded to, Today is chock full of background. We're really laying the groundwork, as it were, for composting. And session 2 is going to be a lot more interactive and is going to build on what we learned today. And we really hope that you will join us for all 3 sessions, as they really do build on each other and interact. So without further ado, I'm excited for the day and turn it over to you, Stephen.
Thank you, David, and thank you, Jenny, as well. Were we meeting in person? So, of course, I would be asking all sorts of questions about what I saw as I was coming into your community. So, if you've already answered this first question online, I'll just have to lead with, tell me something about the weather where you are today. What's going on where you are? And we'll just look at some of the responses on the chat or the Q&A. Our main theme for this webinar series is that composting is a natural process. It's a hopeful life cycle act that's medicine for the earth. And that's what helps us to sustain life. As we get started, I want to share a quick personal story since we're really just stuck with this remote format. I grew up in Los Angeles. I was an urban kid, and I remember being maybe 4 or 5 years old. My family went to the nearby Santa Monica Mountains. We found some arrowheads and also some quartz rocks. And they filled a large sack with the quartz rocks, and I put them in our home garden. Did I think that these rocks would somehow grow well in the garden? Is it possible for a young child to understand something about the healing and transformative powers of quartz? I really don't know. But roll forward 50 years, and now finally, after 30 years of working in recycling and composting professionally, I'm truly deeply humbled and appreciative of this opportunity to work together with Indigenous people, with tribes, with you, on starting and expanding community composting programs. I wish to thank the EPA and my colleagues for their creative spirit of cooperation and service. And this remote format is quite challenging. We will be talking about making compost, yet we won't get a chance to engage our senses, especially of touch, smell, and sight. But as Jenny said, this is an amazing opportunity for us to come together as best we can to share, to learn, and to discover together. So thank you for being here. I welcome your participation. Well, let's get into what is composting. In this section, we'll discuss what composting is and various descriptions of composting. So what is composting? Next slide, please. Composting, at its core, the act of helping organic material to break down into its essential elements to nourish the land. And by organic, we're not talking about like organic food, that doesn't have pesticides in it. It's just anything that once was alive that contains carbon is considered organic. So things like leaves, grass, corn, fish, compost is a natural process. And I want to share with you 4 perspectives or views to the act of composting, some of which are a bit head spinning, some of which I think are much more accessible, all of which are valid. There's a deep technical and scientific background for composting, as we'll see on the next slide. And I want to explain some of the words here. But honestly, the scientific and technical views can get unnecessarily complicated, not only for community members, but also for ourselves as participants in this seminar. So let's look at the technical view. This one I'll read quickly. Compost means the product resulting from the controlled biological decomposition of organic waste that are source separated from the municipal solid waste stream or which are separated at a centralized facility. So that's one definition. That's from the state of California Public Resources Code. So that's in the law. First, compost is viewed as a product. It's used on land. There's an emphasis on control, as in controlled biological decomposition. And for us, this just means helping to speed up a natural process. Organic refers to anything with the element carbon in it, like plants and animals. Wastes, well, that's a term we really don't like to use. Waste is a social construct. It's more of a verb, an act, an action. It's not a thing. One wastes something. Something isn't just naturally waste. Waste is in the eyes of the beholder. Nature wastes nothing. Nature is the ultimate recycler, and composting is recycling naturally. Source separation means keeping good stuff that we're going to compost separate from other things like bottles, cans, plastics, and batteries. On the scientific view, which I won't read, you can see it there on the screen, I've highlighted some words. Biological decomposition, let's call that breakdown. And a quick example, a leaf loses its leaf structure and color as it composts. It breaks down into its essential parts as it returns to the soil. Thermophilic. I wonder how many people have heard this term before. It's just a fancy way of saying hot within a specific range of temperature. The microbes, the small little critters that are doing the actual breaking down of the composting material create heat. Those are the technical and the scientific views. Let's move on to the next view, a chef's view. Here's some other perspectives. If you've ever cooked in a restaurant, did you need a college degree in chemistry to learn how to bake bread? Or a class in microbiology to know the difference between undercooked meat and really nicely prepared meat on your home or stovetop? Good compost, like good cooking, is a mix of chemistry and alchemy with equal parts magic, love, and intent. And that's what makes it so nourishing. And while it's possible to use a cookbook, if there were one for composting, the best way to learn how to become a good chef is to learn from experienced people and to learn from one's own mistakes and successes. And that's really the same is true with becoming a good composter. This, by the way, that's a picture of Wiggle E. Worm, who featured prominently in home composting education programs in the San Francisco Bay Area for a number of years. So that was the chef's view. The poet's view is this. The poet's view is the closest thing that I've found that gets at the spiritual quality of compost and the composting process. Fundamentally, composting is a recognition of the cycles of life, of growth and decay and regrowth. And I would say, in working with a lot of municipal public works directors and others over the years, that it's that cycle of life that can make some people uncomfortable, that things grow and then decay and break down and then there's regrowth. So if that viewpoint doesn't speak to you, don't worry, just call composting an optimistic science in which mistakes can become positives. And still, please don't shy away from deeper values if they speak to you when talking about why composting on your land matters. In my view, and in the view of many people, making your own compost is much more valuable than buying a bag of it from a big box store. And in the same way, growing at least some of our food is a way to return food to its rightful place in our lives, and not just as a commodity to be bought with money and consumed. David, I'm wondering if you would be so motivated as to read this Walt Whitman poem.
Sure, I'll do my best, Walt Whitman. It's a moving topic. I'm glad you're raising this aspect of it, Steve. Behold this compost. Behold it well. The grass of spring covers the prairies. The bee bursts noiselessly through the mold in the garden. The delicate spear of the onion pierces upward. The apple buds cluster together on the apple branches. The resurrection of the wheat appears with pale visage out of its graves. The tinge awakes over the willow tree and the mulberry tree. Out of its little hill faithfully rise the potato's dark green leaves. Out of its hill rises the yellow maize stalk. The lilacs bloom in the dooryards. The summer growth is innocent and disdainful above all those strata of sour dead. What chemistry the earth gives such divine materials.
Oh, thank you so much, David. I think this is one of the very few times in my professional life that I've brought poetry into the conversation, and I can see doing that again. Thank you for sharing the poem, David. Appreciate it.
Thank
We're
you,
going to
Stephen.
talk
Just
next about.
Stephen, just two quick
Yes.
notes before we go on. One, wanted to give the quick results of the poll from poetry to polls.
Oh, thank you.
It was pretty evenly spread among the first three of seed, seedling, and plant. We're at about 19%, 25%, and 21%. 7% were flowers, and 28% chose not to answer because they're still exploring their roots, I'm sure. And then I also just wanted to mention to folks, when you do comment in the chat box, if you can or you're comfortable, select the all group as opposed to messaging individuals. I'm hearing that some of the messages are not going to all panelists, and it would be nice to share that dialogue if you're so moved. And then, as I said, if you have specific questions for Q&A or for Stephen, put those in the Q&A, and I will monitor those and try to get those to Stephen. So thanks. Back to you, Stephen.
Thank you. And I'm noticing in the chat, seeing in some places that the air quality is poor. I know I have not been outside in a week where I live. In Berkeley, California, where the air is very poor. In Olympia, Washington, I see that it's 60 degrees and overcast, so that we do have some semblance of what passes as normal these days somewhere. All right, benefits of composting. Now that we've covered what composting is, let's look at some of the benefits. Next slide, please. And so this slide, let's talk for a minute about the amount of compostable materials overall in the whole country. Municipal solid waste, MSW as it's known, that is the materials and trash that we throw out from our homes, our businesses, and institutions. And the estimate for 2017 was that 268 million tons was generated of stuff. This is more than 1,600 pounds generated per person per year. And that's like 10 times somebody's average weight per year. How is that possible? It's a staggeringly large number, and it doubles what's in Europe. Now, food scraps or wasted food, yard trimmings, which are leaves, grass, brush, branches, weeds, and wood, together, those three circled categories there represent over 1/3 of this total amount. So that's close to heading toward 100 million tons a year. That's just phenomenal. And that gives us a huge opportunity to compost and divert materials that are being wasted. Again, it's a verb, it's not a thing, being wasted from our landfills. Nationally, much progress has been made over the past 30 years to compost or to grind up yard trimmings and to recycle paper, glass, and metal. I wrote my master's thesis at Cornell University in the late 1980s on the economics of large-scale composting. And at the time, I was aware of fewer than 25 large-scale compost facilities in the whole country. And now there's over 3,000 large-scale facilities and an unknown but large and increasing number of community-scale composting efforts. Much more work remains. We need to work on food scraps in particular in cities and deal with that. We need to recognize the high value that community composting, that community scale composting provides, whether it's in an urban, rural, or other area. Let's go on. And with that said, reducing food waste, is a higher priority than composting that wasted food. And let's keep that in mind. The best use of food is to feed people. Going on. And the EPA has strategies, tools, and tips for reducing wasted food in your home and community. There's a link here, and this information is available to you after this presentation as well, and it'll be in additional resources. Okay, I'm doing a quick time check, David, just to see where we are. And we're close to where we need to be. Okay.
Yep, exactly. Great.
Next one, please. So moving into the benefits of community composting. Let's look at the benefits of community composting. There are many. I've listed merely some of them, and not necessarily in the order of priority that you would have. Let's run through these. By keeping organic materials out of a landfill, you can reduce methane emissions. And when released to the atmosphere, methane gas contributes to climate change. Methane is created when bacteria break down the landfilled organic materials without the presence of oxygen. Keeping food waste and yard trimmings out of landfills reduces the greenhouse gas emissions that contribute to climate change. So that's one thing. It also can reduce, just overall, reducing the need for and the costs of landfilling. Other benefits include a reduction in open burning of wood and landscape trimmings. And unlike recycling markets, which can be international, you have complete control over composting in the sense that it occurs on your lands, and how organic materials generated on your lands are managed. There's a possibility, no promise, but there's a possibility that there may be some job opportunities associated with community composting as well. I'd be curious to hear from participants what you think are some additional benefits of community composting and of using compost. And if you would like to share some of that in the chat, please go ahead now. And David, if you can capture those, we'll read them out.
Great.
I'm going to just pause for a second here. Well, as people are considering that, and maybe I did cover several of them, I'm sure if we were meeting in person, we would be discussing this topic in much greater detail of what is it that would be the real driver, the real motivator for developing or expanding a community composting program in your community. And we will have that opportunity as we move through the other sessions to begin to really discuss those topics. But that is certainly what we hope that you'll bring to the conversation and share that with all of us.
And Stephen, there are some great comments coming in. For folks who aren't monitoring the chat, I'll just run through a couple of them. Reducing cost of solid waste collection, getting people of different ages and physical abilities involved in a mutual goal. Soil amendment, we're trying to grow food in sand, said another columnist. And now they're coming in so quickly, I can barely keep up. Let me read one more. The philosophical take, with growing the food, eating the food, and taking the scraps to compost to grow more food, and the cycle goes on, shows the community members how the whole cycle works, which we can sometimes be so very far from. And there are a number of other great comments here, including it's a way to prevent illegal dumping. So I'll turn it back to you, Stephen.
Thank you. And maybe what we can do is capture those in some other succinct format and just share that after the session in some way.
Great.
All right. On the benefits of, so the next slide, as we just discussed, compost consists of decomposed organic matter. And it's the organic matter and what's in it that holds fertile soil together. When soils lack enough organic matter, hillsides erode, stream banks erode, soils get tired and hard and brittle. Concrete doesn't hold water, and neither does soil that lacks sufficient organic matter. You know this very well if you live in certain areas of the country. Plants struggle to grow well. Communities suffer from more frequent and devastating flash floods. Fish in streams have a hard time dealing with all the small particles known as silt and contaminants that wash into streams when the land doesn't have enough organic matter to hold these particles in place. So that's what we're dealing with in many cases. Compost absorbs water, it holds water, it makes water more available to plants when they need it. It holds soil in place. Compost allows soil to breathe. Compost allows roots to grow, and it promotes a healthy ecology of life in the soil. Okay. I want to spend the next perhaps 8 minutes or so, David. I want to spend about the next 8 minutes, everyone, on these next 3 slides, which are about a topic that's considered a subset of composting. Some consider it separate, some consider it a subset, and that's mulch and mulching. And I want to start with definitions and then go through benefits and uses, and then just a few specific tips. Mulch is organic materials that are spread on the top of soil to conserve water, control weeds, beautify the landscape, and help plants to grow. Mulching is a mechanical process, and we reduce the particle size. We reduce the particle size by chopping, grinding, or shredding whatever the materials are that we're working with to make the mulch. And so one is the product and one is the process. The benefits are reduced weeding, reduced labor time, decreased need for herbicides, reducing the need for trimming grass around trees and poles, conserving water, cutting the cost of irrigation. Those are some of them. Reduce competition from weeds, keeping the soil moist, adding organic matter, preventing soil compaction, improving soil structure, on and on and on. Okay, a main one on here is reduced fire risk. In summer, 2 inches, I want to talk about water conservation for a minute. In summer, 2 inches of mulch added to the surface can cut water loss by 20%, an estimated 20%, and lower temperature in the top 4 inches of soil by 10 degrees. When you lower the temperature in soil by a lot when it's 100, 110 degrees out, the plants are going to have a better chance of surviving. And when the soil sediments wash into creeks and streams, fish and other creatures have a harder time living, as we discussed. So soil erosion. By using mulch, we can reduce soil erosion. It holds the soil in place when it's exposed to rain and pelting rain and wind. And when we reduce stormwater runoff speed, we reduce the potential for creek channel erosion. So all of that's helpful. Mulching can reduce fire risk in 2 key ways, and there are more. First, mulching dead trees, branches, and brush can reduce the amount of easily flammable materials in sensitive areas. And by applying mulch to ground reduces flammable weeds. And once it's spread out, the mulch generally poses a much lower fire risk. Application rates, rule of thumb, 2 to 6 inches deep of mulch every year or 2 typically will give good results for plant beds and weed control and pathways. And we're talking about what can be a lot of material if you can generate it. For an area of 1,000 square feet, which is 100 feet by 10 feet or 30 by 30 roughly, a 4-inch layer of mulch, if I did the math correctly, is about 12 cubic yards of material. The types of materials that are suitable for mulching are broken pallets, used lumber, tree stumps, dead trees, tree branches, brush, and other woody and fibrous plants. make sure you have stored piles of mulch not too high, less than 8 feet, because they can catch on fire by themselves. So it's best to have a water source available. Let's see, I want to check time again here.
And
Yeah.
Stephen, while you're doing that, I'll just mention we're working. Thanks for the heads up on the chat function. It sounds like the folks that are out there are not able to select all attendees and are only able to select all panelists. So the chats aren't going to everybody. At least that's what I think I'm deciphering. So we're working on it, and just wanted to let you know that. And Stephen, you can continue. Thanks.
Okay, thank you. I'm going to move ahead one, although there's one item on here that I want to cover, or at least just highlight. Reduces salt buildup on soil surface. This is one that I think we're going to see a lot more of this issue. It's certainly happening in the Central Valley in California, where people are losing access to clean drinking water, and having also to begin to think about switching the types of plants that they grow just because of the salt buildup that comes both naturally and not so naturally. And I won't go through all the processes on that, but basically using mulch can help reduce the salt buildup too on the soil surface. I don't know how much research there's really been on that topic. That's more anecdotally from my circles, and I would love to see a type of research project on that, about the relationship between using both mulch and compost, and staving off, keeping away some of the salt buildup that may occur and affect both drinking water and plants. Let's go on to the next slide, please. Oh, how is mulch different from compost? First, the materials. Mulches tend to use woodier, more fibrous materials than compost. And composting and mulching are complementary strategies. So in some cases, especially where brush fire and wildland fire dangers are high, grinding woody materials may be of higher value to your community than composting. It's important to assess your community's needs on this topic and other topics like this, which we will discuss in particular. I believe it's in webinar 3. I want to open it for a minute here, David, to questions about mulch and mulching, or even just a quick comment about whether there's experience in doing this on a community scale.
Great. What I'm going to do is monitor the comments that come in to all panelists in case that's the only way people are able to communicate. But I do think it's fixed. And oh yeah, it looks like now people have an option for everyone. So one person, Allison, just selected that, and hopefully everybody is seeing that. So I think hopefully that's working, and maybe you even have an all panel, or yeah, and all participants selection would be the best. But one person did comment, Stephen, that yes, salts are a problem.
Mm-hmm. And is that someone in California or somewhere else? I'm curious.
I can't tell, and I'm not sure how comfortable people are with being named along with their comments, even though it is public. But,
okay, that's fine.
She said her garden's in New Mexico.
Mm-hmm.
Thanks so much.
All right, so we've covered what composting is, and compost and mulch and mulching, and we're going to go through what amounts to probably about half an hour of moving quickly through the science of composting. And then after that, we will have some opportunity for a question and answer session. We may take questions along the way, so do, as you have questions and comments, do share them just as they spring to mind. We would really appreciate that. And with that, let's see what's on the next slide, the science. So in this section, you'll learn the basics behind composting science, which in essence will teach you how to compost and the results you can get. And the science boils down to understanding and managing the 4 big ingredients. And doing this by computer screen is really quite a challenge. So, we're just going to have to do as best we can with this section as is, and imagine that this is hands-on. So, and you see this picture here. So, feedstock, well, that you can think of that as food, but it's not just like fruits and vegetables and things you eat. Feedstock and food there can mean anything that the microbes are going to munch on, which could include landscape trimmings and other things as well. So that's why we use the term feedstock instead of food. But if we were doing this for especially a very young audience, we would probably refer to it as food, water, air, and time. So feedstocks are the raw materials used during composting. I'm going to go back to that one. It's important to have a sense of the characteristics of the feedstocks to be composted, and feedstocks are characterized by their carbon to nitrogen ratio. You can stay on that slide there. What we call greens provides nitrogen, and what we call browns supply carbon. The microbes need both, kind of like needing protein. Greens are kind of like protein-ish, and the browns are kind of carbohydrate-like for us. The browns can also serve as what we call a bulking agent, which is what provides air spaces. You might see porosity in the pile, and that way microbes can get the oxygen or air that they need to thrive. A proper mix, a proper balance of green feedstocks, which contain larger amounts of nitrogen, and brown feedstocks, which contain larger amounts of carbon but limited nitrogen, is needed for effective composting. So we're going to look at some of the materials in each of these categories. So on the brown side, leaves, typically, you see these lists: leaves, straw, corn stalks, some pine needles, some woody plant prunings that are chopped up. On the green side, fruit and vegetable scraps, coffee, hair, that didn't get on here, but hair, grass clippings, animal manure from herbivores, fresh alfalfa, hay, that type of thing, even seaweed. So it's a question of creating a mix of this material. And so this is where we get into the chef's side, where it involves some degree. There may be a kind of a loose recipe, but it's some degree of experimentation as well. Let's move on to the next one. Sorry, I want to make a few more. You can stay there, but I want to make a few more comments on greens and browns. So the browns tend to be drier and more fibrous, and sometimes they're brown, not always. The grains tend to be wetter with less structure, and yes, they often are green, but not always. So an example is fresh grass clippings. When it starts to dry out, it's still kind of greenish for a while as far as the nitrogen level, but it doesn't look green. And when it's really dry, it's the nitrogen's not, it may have left that material. So I like leaves that fall from the tree each year, deciduous leaves, as sort of like, if you've got those, and a lot of people who are in the upper Midwest do, that's somewhere between a green and a brown, and is an ideal starting place for composting. An even mix of greens and browns by weight by weight is likely to fall within the target carbon to nitrogen ratio, which is 30 or 40 to 1, that makes for more rapid and effective composting. And I see, even though I can't see any of you, I'm just imagining seeing some of you just scribbling down, oh gosh, we need to have a carbon nitrogen ratio of 30 to 40 to 1. How are we going to measure that? Blah, blah, blah. That's not what we're doing at all here. All of this is done by eyeball. That's what I would expect here, and we can be successful with it. Next slide, please. So here's one example. So if you had a cubic yard of leaves, which would fill an average compost bin made from wood pallets, let's say, you could add 3, 4, 5-gallon buckets of food scraps into the middle of that, those leaves, those deciduous leaves, and that would be a great way to start. If you didn't have the food, that's okay. If you do, that's fine. If you don't have the leaves, we're going to look at other materials. But I wanted to give you one visual description of a mix of greens and browns that will result in a good starting carbon to nitrogen ratio. And on the next slide, we'll look at various recipes. And again, you'll come up with your own using the materials that you have or can find easily. And I can assure you that if we were meeting in person, this is a lot of what we would be focusing on, would be going around the setting that we're in, and a combination of seeing what we see, just like, oh, yep, that's pretty obvious, and then perhaps discovering some less easily visible, or something that immediately springs to mind, other things that we might be able to put in a compost pile. So these are sample mixes. Again, I'm just checking where I am on my time here. Okay.
Yeah, I think you're doing well. You're in the mix there.
So here are some sample mixes, and so just leaves, deciduous leaves, you're golden. Next one, leaves with some fresh grass or not so fresh grass, you're golden. Leaves with some food scraps, a small amount, and some woody prunings that ideally are chopped a little bit. So say there were some branches and you chop them up a bit, that's good. Animal bedding, you've got some animals, so you know, some goats or cows, and maybe there's some straw, and you've got the manure from the animals and some straw, and you throw that into, or you just compost that by itself. That can work too. Leaves, animal bedding, and chopped up woody prunings, that works. You could add a small amount of shredded paper. And then worm composting is a special separate case that can work particularly for food scraps with a small amount of shredded paper or straw. Okay. So 3 main categories of feedstocks are most often used: yard trimmings, food scraps, and paper. And so we're going to look at these in a little more detail and talk about yard trimmings. Some people use the term yard waste. I try not to use the term waste. Again, I think of waste as an action and not a thing. And nobody really wants to deal with wastes. So I tend to think of these as valuable materials that we're going to do something with. So yard trimmings I break into 3 categories: leaves, grass clippings, and brushy or woody materials. The leaves are the easiest to compost. They decompose pretty well. You can compost them alone or mix them with other materials. And grass clippings are reasonably simple to compost, provided that they're mixed with leaves. But if you have a huge amount of fresh grass clippings and you're trying to compost that alone without other materials, you can run into difficulty because they decompose so quickly And actually, if they're mixed in with a big pile of woody material and that woody material is not shredded, say you've got a bunch of grass and then you put on a bunch of landscape trimmings, brushy stuff, and you pile that on top of the grass and you leave it untended, it can catch on fire. So it's important to mix the grass clippings in well with other materials. And the brush and woody materials, I like to see that ground up or shredded and used directly as a mulch, ideally. It can be composted with other materials in smaller amounts. It doesn't decompose very quickly because it doesn't have much nitrogen in it. And again, careful about stockpiling it with grass clippings. Okay, next. Food scraps. So again, in our field, and oftentimes the term is food waste. I've always tried to use food scraps or the term organics to describe a combination of food scraps plus compostable, non-recyclable paper plus compostable yard trimmings. That's organics. Food scraps are broken into two categories. One is vegetative food scraps and non-vegetative. So vegetative is food, like fruits and vegetables, no animal origin food there. It's, you see a picture of a banana peel there. It's relatively easy to compost. It's fairly similar to composting yard trimmings. It works pretty well. It does require other materials that have more carbon in it to mix with. So that's something that can work at a household level quite easily. It's something that can work in a place like a casino as well, with some training efforts for the staff to make sure that you're getting the right material that you need. You can add meat and dairy and vegetative, so all types of food scraps, to a compost pile. It's not recommended to do that at home. It's recommended to do that in a larger compost pile, because when you're adding meat, particularly meat, to compost pile, when you're handling meat and then composting it, you have to hit certain temperatures within the pile to make sure that the pathogens, potential pathogens in decaying meat, are killed off. And it also might attract animals as well. So it can be done. It takes more care and attention to do it, and to do it well is absolutely essential. So if you're thinking about, say you already have some type of program with landscape trimmings, the next step might be to consider adding in vegetative food scraps and get comfortable with that, and then expand it if the setting is conducive to it, if you have the right setup, to adding in meat products as well. Okay, next slide. Okay, let's see. Okay, so we covered feedstocks, the food. Now we're covering water. Now, compost piles need water, and like everything else, not too little, not too much. The target starting range is 40 to 60% water by weight. No need to write that down. We're going to use the eyeball test on this when we're doing this in real life, which is the squeeze test. So you grab some material that's in your pile and you squeeze it, and it should be, like drops shouldn't be coming out the bottom from your hand. It should be as wet as a wrung out sponge, and there shouldn't be a lot of like slimy stuff that sticks to your hand. That's way too wet. And then likewise, if you grab it and it just kind of turns to dust and there's just nothing left on your hand, there's no residue at all, and it's dry, it's way too dry. So the microbes, the ones doing the actual breaking down of the composting material, they need water. So, and they like this particular range of water. So here's a picture of a hose. There's irrigation systems that you can set up. And if you don't have access to water supply on a regular basis, but there's still some ways to compost as well. The default, the ideal is to have a water source, like a hose or a sprinkler type of system. And it's important to get the water into the pile itself and not just on top of the pile. See, that hose is actually pushing into the pile, and then you would move it around. Okay. So just a finer point, the composting material about a foot deep inside the pile should be as wet as a wrung out sponge. So damp, but not dripping wet. And that can be a fairly reliable test. So what happens if it's too wet? You can add brown materials, which are drier and can absorb some of the moisture, or you can use a cover, a tarp, or some type of open air structure. If it's too dry, you can add green materials, which tend to be wetter. You can add more water, which is the most important thing, or use a pile cover, a tarp, or even mulch or compost that's already done to hold in moisture. It's possible to reduce the drying effects of wind by adding in some type of wind break, like having some trees or just even a tall mound of dirt that's near where the compost piles are, or just move the compost pile to a less windy area. In the arid Southwest in particular, tarps or mulch can be used to help maintain pile moisture, and in the very wet Northwest can help to reduce the amount of moisture getting in. Okay, so that's water.
Stephen, I know you've got about 10 minutes left on the science section, but some interesting chat is going on. I'll hold some of the questions until the end because they aren't quite as directly related to what you're talking about. But there are some, one question came in about using gray water from showers or dishes to moisten a compost pile. Is that advisable? How can you figure out a way to do that? And somebody else commented they'd like to hear more about mulching for fire reduction. And I think some
very good. Thank you for bringing those up. And so the gray water one. So gray water. So reusing water. Water should never be used just once. Water should always be used more than once, in my opinion. And so using gray water, which is basically, as the person said, they've got dishwater. Did I hear that correctly? And then they're wondering, as they capture the dishwater, can they use that in their compost pile? Was that the question?
Yeah, and even shower water.
And shower water as well. So what happens with that, with using soaps, and it would be useful to use a more natural type of soap with a cleanser with less chemicals in it, and those are available, or you can make them yourself or just use simpler materials. There's still, with gray water, there is some residual salty material. It has higher salt content than natural water, or than like fresh water does. And so it is possible to use. It's a question of checking out how, it's calibrating how much can I use before the compost ends up being too salty. And so it's again, that I'm all for doing small scale experimentation, and especially if you can tie in a some other entities like the State Cooperative Extension Service and do a research project, or the EPA, or some other group that's interested in these topic areas, because the research results are very useful in all sorts of settings. What happens on particularly arid land that may be prone to salt buildup to begin with, and here we are trying to conserve as much water as we can, and so we need to reuse the gray water. I would love to understand that more clearly, and I think the results would be particularly useful to a great many people. So I think the short answer there is try it in small, push it a little bit more, see what happens, and do it over time. The other question was about hearing more about mulch and fire reduction, was it?
Yeah.
So, I live in California, a lot of the state's on fire right now. And a lot of the efforts, I think, in terms of organics management need to be more on taking particularly dead, deadfall, dead trees, and things that are near our houses and our buildings that are brushy, and grinding them up or shredding them. And so if the equipment that is needed is anywhere from a small kind of almost hand operated system to something that's fairly substantial and large, and that might spit out wood chips into the back of anywhere from a pickup truck to a larger truck, that type of operation may be the starting point for many communities that are at acute risk of fire, and that I think can go under the environmental category of organics management. I would hope it can for the various agencies that you might, if there's funding to be applied for or sought from outside agencies for help in this matter. I hope that begins to answer the question there.
Yeah, I think that's good for now. And there are a couple other comments regarding gray water and insects and other nuisances. But you may be, and so I'll circle back around to.
Yeah, let's save the nuisances and animals and all that for in a little bit, and I'll move on here. Okay, so aerobic composting. I'm just doing my time check. Right. Okay. So compost piles need air, so that's the third ingredient. And the little critters, the microbes, need air to breathe. And so as you read about composting, you may see the term aerobic to describe composting. Certainly you hear it to describe exercise, and it means with oxygen. And so I just call it air for simple terms. And if there's not enough air in the compost pile, then the so-called good microbes die off, and what comes in are anaerobic microbes, different type of microbes. They don't use air, and they end up smelling, or what they produce ends up smelling. So we we want to have the aerobic ones. Plus, the composting happens more completely and better with the aerobic ones. Okay, let's go on. So how do I make sure that compost piles have enough air? There's really a couple ways to do it. The first one is having a feedstock mix, a mix of greens and browns, to make sure that there's enough structure in the pile for air to move through. So we need to have enough browns. And again, that's like leaves to wood chips to a bunch of other things that were on that list, that you can look back on, to make sure that there's enough air flowing. And then another way to make sure that there's air that flows through the pile is either by turning it periodically or by passively adding air. So turning the pile involves, if it's a small pile, relatively small, you can use a pitchfork and a strong back. And if it's a much bigger pile, a tractor, front end loader, and there are other larger systems that are specialized compost turners as well. With passive aeration, that involves using pipes like PVC pipes, polyvinyl chloride pipes with little holes in them that are layered in a compost pile. And that's called passive aeration systems. Next, please. So there are three key actions in building your compost pile. If you've got brushy or woody materials, we want to chop them, ideally, mix the greens and the browns, and make sure if you're adding food scraps, to put them at least a foot deep in the pile. So that's where it's going to be warmest, and animals don't like digging through really warm piles. And by warm, I mean it may be over 130 degrees in a foot deep in that pile. So they're not that interested in food at that temperature typically. And so chop, mix, and maintain the air flowing through the pile and maintaining the moisture levels by periodic watering or by using techniques to make sure that there's not too much water. All right, next. And time. This is our last element or ingredient. Composting can be done very quickly. It can be done in as little as 2 months, and it can take up to 18 months. And that's all fine. You can speed it up by managing the feedstock, air, and water more closely and carefully. You can leave it fairly passively as well and just let nature take its course with a little bit of help. The main thing is composting is a forgiving process, and favorable results are possible regardless of how much time it takes. So there's no wrong way here and there's no right way here. There's only figuring out what's going to work best in your particular situation. And if you are composting animal-based food scraps, there are just another cautionary note. It's important to really follow the types of rules that are and requirements that are in place in various states for dealing with such materials. Tribes may not be subject to the same types of rules and regulations that other communities are, but when we're talking about animal-based food scraps, we really need to be careful about making sure that we kill off any possible pathogens, any disease-causing agents within those meat dairy products. So there's some standards that are used about turning piles a certain number of times within a certain number of days and maintaining a certain temperature within the pile. And depending on whether it's a static method, not turning or turning, there's different standards for that. So those are things that if you're going in that direction, that's something that's probably worth talking about separately offline in a way, because it's a fairly sophisticated way of doing things, but I want to at least show that there. So the main thing is that composting can be slow or fast. We don't have to have judgment about whether it's slow or fast, it just is. Let's look at determining when composting is ready on the next slide. Okay, so when is composting ready? When it looks and feels like compost. Oh, great. When it looks and feels and smells like rich, dark earth, rather than what it started as. So the composted material is not easily recognizable. So like, we don't really know what was in it to begin with. And it smells pretty darn good. And it's been composting, cooking along for at least 2 months. There are scientific tests to determine compost maturity, but they're really not needed or recommended for most uses in the local community. A quick note on removing physical contaminants, and again, this is really, I think we're going to have to leave this for a separate conversation about if you have, say, a large casino or some other commercial businesses that generate a lot of food scraps that also might be generating plastics, glass, and metal in the same facility, that it's important to pull out those visible contaminants, plastics, glass, and metal, during and after the composting process. You can pick out some of the larger pieces by hand during and after composting. And for small operations, you can make a simple screen to screen out what I call physical contaminants, plastics, glass, and metal. There are do-it-yourself screens available online. And if you have a larger operation, it's possible to get a screen, but really a lot of the work is upfront to make sure that those other types of contaminants are not getting in very much. Troubleshooting. And let's see, yeah, and then I'm going to have to, let's see, here. Okay, so I've got basically 2 more slides, and then we're going to open it up to questions. And so I'm just going to cover this very quickly, this troubleshooting part, because I think these are some of the questions, and I'll do the last slide, I'll open questions. So general types of problems. The compost pile doesn't heat up, it smells, it's got ants or other animal, and it might have vectors. It's got animals, a fancy word for animals that you don't really want around, that can carry diseases or cause other problems. So the compost pile doesn't heat up. That's the problem. What's causing it? Well, it could be too wet, too dry, and maybe it doesn't have enough nitrogen. And it may not be big enough either. Now, the fact of the matter is that if you're living in a cold climate, a compost pile should still heat up. I remember being in Ohio in January working on a project at a compost facility where it was 5 degrees out Fahrenheit, and I had to go check the temperature of these compost piles, and I had my trusty 4-foot thermometer, and darn it, if it wasn't 145 degrees in 2 feet deep in the pile, even though the outside air temperature was 5 degrees. So it's definitely possible to do composting in cold weather. Okay, so too wet, too dry, not enough nitrogen. You can see the solutions there. They typically involve turning and watering or adding different types of materials. If it's smelling, same types of issues. It's too wet or there's not enough air, you've got to break up. There might be a mat of grass clippings that requires a pitchfork if it's at a home scale or small scale. you want to turn the pile or do something that increases the airflow. Again, water is typically an issue. That's true with ants, as you see. And then if it's attracting animals, it may be that the food scraps are too close to the surface. You can't just dump and run. You've got to like bury the food into the pile, and the pile has to be hot enough so that animals aren't interested in it. It's also in a home scale system or small, very small scale, to use wire mesh, something to keep out unwanted animals. And again, putting the food in the center of the pile and turning it. Okay, next. Okay, that was a lot of science. I'm just checking my time. We do have some time. That was a lot of science. We had to move through it quickly. I want to emphasize that composting is a forgiving, flexible approach to managing materials on your lands. And fundamentally, I view compost as medicine, and composting, including mulching, is a hopeful, caring act for the future. I want to encourage you to attend webinars 2 and 3 in September. And webinar 2 will be much more interactive with examples directly shared by various tribes. I'd like to turn the mic fully over to David, our excellent moderator, to run a short question and answer session, and then to Jenny, our outstanding organizer of this event, along with her colleagues for concluding remarks.
Thanks so much, Stephen. Fantastic. Really great to hear all of that information. And Minna, I'd like to ask you to put up a quick poll. We're going to have a second poll now, just to get some feedback from all of you to help inform our efforts as we go forward in sessions 2 and 3 and repeating session 1 in the future. So there's the poll. Bearing in mind that today was focused on composting fundamentals, and the next 2 sessions are going to focus on practices and community composting programs. How useful did you find today's session? You'll see that under polling. You might need to open that little window. We give you options A through E, and then there are 2 more questions there as well about how do you plan to join the next session and whether you have any questions that didn't get answered. So I think what I'd like to do is leave that poll open and encourage you all to fill that in. And the session is being recorded and will be available later. So just wanted to confirm that. And what I'd like to do now is encourage folks to ask questions. We have about 5 more minutes to ask questions. So put them up in the Q&A box or in the chat box, and I'll try to focus on both of those and track those. So let's see what is coming in. If the environment is too wet due to your area, what would you suggest?
Covering the compost pile. So the least cost would be, say, using a tarp and covering the pile during wet weather. So that'll at least keep the water off the pile. It may be possible to put the compost pile under some type of fairly simple structure. That structure might just be something with a roof and 4 poles. And maybe some of the rain blows from the side, but maybe it's not too bad. Or maybe the structure is large enough so that even if it blows from the side, not much gets in. So that's not that expensive either, necessarily. And you go up from there in terms of degrees of enclosure and protection from moisture. So that's one way, is physically keeping that rain out by using some type of cover or structure. The other way is by adding in more brown material and not use, and so that absorbs some of the moisture. It's possible to use some sawdust. It doesn't compost very well, but it can absorb some water, straw, some other materials like that. I'd be very interested to hear, and we may have to save it for next time, to hear experiences of dealing in very wet environments and what people are doing now to deal with water if they have experience with this. Those are some of my thoughts there.
Great, thanks, Stephen. Next question is, I love this question. It's kind of philosophical, really, although it's also quite practical. If the best use of food is to be eaten, why is it inherently negative for animals to get into your compost pile?
Oh, great question. So, well, ants typically are just kind of, for some people, they're viewed as kind of icky in some way. They're not necessarily harmful. Rats are anywhere from icky to, oh my God, that's horrifying, to they might be dangerous. And then there's bears. And then there's various types of things like coyotes and other animals too. Again, I think that having material, food buried at least a foot into a compost pile, making sure that it's at a reasonably high temperature so that it's at least operating at, say, 120 degrees and maybe as high as 150 or even 155 degrees Fahrenheit, which is fairly reasonable for a compost pile. That would be best to keep the animals away. Compost piles that are, say, like 6 feet high, 8 feet high, 6 feet wide, and fairly long, so like what's called a windrow, those the temperatures in those can run above 140 degrees for well over a month. And so it's, you know, if operated reasonably well. So I've worked with operations that are adding in food scraps, including meat scraps, that don't have problems with animals of really of any type. So that's the thought on animals.
Great. Thanks, Stephen. I think I'm going to make sure to save some time for Jenny to share some additional resources and other comments. And other questions came in and I'm sure they would continue about your thoughts on tumblers for composting and other things. So we'll review these questions and make sure that we can address them perhaps even in sessions 2 and 3. But for now, I want to thank you and thank everybody who's been listening and participating, and turn it over to Jenny.
Awesome. Yes, thank you. And I've gotten some feedback that folks might not be able to submit their polling responses. You might just need to write in something in question 3 to like fill it either not applicable or ask a question, and then should be able to submit it. So if you can respond to that polling question, that'd be great feedback. I want to highlight here, and the hyperlinks will be available in the slides that we send out, but here are some additional resources. As Stephen had highlighted earlier, EPA Sustainable Management of Food webpage. And then if this isn't enough, I do want to highlight there's a lot of other additional training courses on composting, and they're listed here as well. And then want to also, another resource, humans, want to share with you our contact information here. Minna, if you can go to the next slide. Yeah, with EPA. So a lot of folks are joined today from our region 6, 9, and 10. If you don't see your region listed, please click on that bottom hyperlink and you can find your EPA Tribal Solid Waste contact. And we love to help. So if you are looking to start a composting program, you have questions, you want to dive more into the details, please reach out and we're here. So here's our contact information there. And this is just the first of 3 sessions. So as David and Stephen mentioned, we really hope that you join us in the next ones. And that gets us, we'll hopefully see you next time on September 9th. Please register. Each webinar has a different link. So if you haven't already registered, please register. And this session will really get into identifying the community composting practices, seeing some, we can dive into the details on, pick Stephen's thoughts on tumblers and, you know, like all the other things of like, what might work best, and really see what solutions work well. Maybe some folks have used deconstructed materials to make the covers for their compost piles and what areas. Yeah, I'll turn it back to David to close us out.
Great. Thanks so much, everybody. We will review, as I said, the questions to make sure that we can address those in the next 2 sections, and hope that you will join us on the remaining parts. And we look forward to seeing you on Wednesday. Thanks so much, everybody. Take care.